Today's lesson is going to focus on special right triangles and the unit circle. Before we can actually talk about the unit circle, we do need to just go back and review our right triangles from geometry. So our first right triangle that we have here is a 60, 30, 90. And then this next one is a 45, 45, 90. And then lastly, a 30, 60, 90. Which is exactly the same as the first one, but for what we're doing today, I wanted to have them be separate so you could kind of see how the angle measurements are going to differ just slightly. So let me get, that's this one. And so I've basically marked just the angles that we need. So 60 degrees is here. This side length over here is a radical 3/2. This side length here is a 1/2. And then this side is 1. So just a couple things to go over before we start. The first thing is that when you're talking about a specific angle, so for instance, the 60 degrees here, the angle that's completely opposite on the other side is what would be considered our opposite side. And the angle that is right next to is considered our adjacent side. So in a 60-degree angle, a radical 3/2 is our opposite length, and 1/2 is our adjacent. And then hopefully we all remember that across from the right angle, that's our hypotenuse side. It's always the angle that's across from the right angle. Sorry, hypotenuse got spelled a little weird. So same thing on this one. So we have a 45 degrees here. This side is actually a radical 2/2. This one's also a radical 2/2 since both of these have the same sides and same angles. But again, just for clarification purposes, if we were to go across, this would be our opposite side. Next to would be our adjacent side. And across from the right angle would be our hypotenuse side. And I will spell it a little bit better there. So it's hypot and then the number 10 and then like the word use, hypotenuse. And then lastly for our 30, 60, 90 triangle, this side over here is going to be 1/2. Sorry, my hand's totally in the way. And then here, this is going to be a radical 3/2. And then again, if we're to mark the angles, so coming across here, this will be our opposite side. Next to is our adjacent side. And then across from the right angle is our hypotenuse. So we are going to use these triangles in order to find sine, cosine, and tangent. And so hopefully we remember that. If not, we're reviewing today. So that's basically what we're going over is how to find the different values. So I wanted to just touch on these. So first off, sine, you have SOH. So I'm not sure if we remember SOHCAHTOA. SOHCAHTOA is a tool to help you remember which side goes over which. And for sine, we have an O and an H. So sine is opposite over hypotenuse. So sine is opposite over hypotenuse. Then for cosine, we have CA, so CAH. So it's adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And then lastly, we have tangent, TOA, which is going to represent opposite over adjacent. So what we're going to do is we're going to first find sine 60, cosine 60, and tangent of 60, but I'm going to kind of let's see, I'm going to spread it out a little differently just so you can really make sure you understand what we're doing. So I'm going to basically take this triangle from up here because we're going to be finding 60 degrees, and I'm going to copy it down here to this triangle. And then I'm going to show you how to match the sides to figure out what these are. And then we'll find the sine and of 45 degrees and 30 degrees as well. But we won't draw the triangles for these two, just for this one. So if we go ahead and draw our triangle from above, so we said the 60 degrees was here. This bottom length is a 1/2. Here's a radical 3/2. Here's a 1, and here's our right angle. And if we label it like we did up on top, we know across, so this will be our opposite side. And then here's our adjacent. Now you don't have to do this for all of them. I just want to really make sure, I know it's hard since we are not together, to try to explain something from a video. So I'm trying to really make sure it makes sense. So for sine of 60, sine we know is opposite over hypotenuse. So if I go, here's 60, opposite is radical 3/2, and hypotenuse is 1. So our sine is going to be radical 3/2 over 1. We know that anything over 1 is just the numerator, so radical 3/2 will be the value for 60 degrees. And you will not be using a calculator to work this out, not at this point. Then we're going to go to cosine. Cosine is adjacent over hypotenuse. And again, use your memorization tool, the SOHCAHTOA, to help you. So adjacent over a hypotenuse. So again, here's my 60. Adjacent side is next to, so 1/2 over hypotenuse, which is 1. So 1/2 over 1. But 1/2 over 1 is just 1/2. And then lastly, tangent, which is opposite over adjacent. So opposite is radical 3/2 over adjacent, which is 1/2. And this may be a little intimidating because it's pretty ugly. But one thing you can do is think of how this would look if you rewrote it a different way. So like radical 3/2 divided by 1/2. And what we would do is, we always know that we flip this one and we change this to multiplication. So this would be radical 3/2 times 2/1. And then your 2's are diagonal, so you can cancel those. So you're going to end up getting a radical 3. Now, I don't want you to do this work all the time. I'm just trying to show you why I'm going to do the next step. So both these denominators, I'm allowed to just cross them off because technically it would flip and come up, making it so I could cross cancel it. So I just want you to realize that anytime you have a fraction over a fraction, basically your denominators, if they're the same, you can cross cancel them. And then I'm left with radical 3/1, which is just radical 3. If you want to pause the video before I do the next set, I am not going to show the triangles for these, but all you need to do is come back up here to the top. Here's your 45, here's your 30. You have all the sides labeled and you can go through and work those out. I'm just going to quickly go through them. All right, so sine of 45. Sine we know is opposite over hypotenuse, so opposite would give us this radical 2/2 over hypotenuse, which is 1. So radical 2/2, and I'm going to write everything out just so you can see it. So I know that that's just radical 2/2 because the 1 has no bearing on the denominator. Cosine of 45, if I go up here, cosine is adjacent over hypotenuse, radical 2/2 over 1, which again is just radical 2/2. And that's what's nice about a 45, 45, 90. Tangent now is going to be opposite over adjacent. Opposite was radical 2/2. Adjacent is radical 2/2. When you have the same thing on top and bottom, it just cancels to be 1. Sine of 30 degrees. So if I go to my 30-degree triangle, I want opposite, so 1/2 over hypotenuse, which is 1. And you can totally eliminate the step that I'm putting here with this 1. You don't need to do it. Again, I'm just trying to show a little bit extra. Cosine will be adjacent, so it'll be a radical 3/2 over 1, which again is just radical 3/2. Tangent will be opposite, so 1/2 over adjacent, radical 3 over 2. And from the previous example, we know that these 2's in the denominator will end up canceling off if I were to actually show the work again. And again, the work was right here to show why it cross cancels. And I'm left with 1 over radical 3. Now the problem with 1 over radical 3 is that we're not allowed to have radicals in the denominator, so you cannot leave a radical in your denominator, so we multiply top and bottom by that same radical in order to make the radical cancel. So this will give me a radical 3 on top, and then radical 3 and radical 3 is radical 9, but that's just 3. And so you get rad 3 over 3.